G'day everyone, welcome back to In My Shed. I'm BC. A little talk on angle grinder wheels today, and I put exposed because there's a lot of info some of you might not know about. Abrasives are a really broad subject. Quite a lot of tradesmen call them grinding things. Well, you've got to have a better understanding than that, and a better understanding can lead to easier work and a hell of a lot of improvement in productivity. One prime example, just before I sold up, the Cubitron grinding wheels by 3M and their sandy discs were really taking the industry by storm in well prep, removing metal at a fantastic rate, but they just could not worry their way through the mill scale. Our mill scale is a metal oxide. Your main grinding wheel is aluminium oxide for steel, so they're very, very similar materials. And the mill scale is actually a little bit harder than the Alox, and the grain just couldn't penetrate. Even the Cubitron very sharp ceramic, if you pushed it hard enough it would shed grain. It just was not as aggressive there. So a few hints about what you can do there as we go down the tree of abrasives. You do need to have two grinders, not one, but if you can lift your product up substantially and reduce your cost substantially, I think it makes it worthwhile. So enough gas bagging from here. I'll zoom you in. You can see my wonderful chart, and I've got a few samples here that I've collected over the years, just a little bit that I've got left after I moved. So I'll bring you in closer, we'll have more of a talk. Okay, this will have to be a little bit like that simulated demonstration you see on TV. I haven't got a wide angle lens for the camcorder yet. Basically we'll run down what has been popular over the years. I've only been around for a couple of centuries in this industry. Everything that you've seen up until about 20 years ago was aluminium oxide in the main. That's oxide of aluminium. Obviously it's fused with high current, crushed into grain, sieved into your different grades, and it does a hell of a good job. It comes in many different forms. Type 1 or straight wheel. They used to all be 3 to 3.2 thick, and it won't stand up against the hat. They're now usually about 2.5 mil to give you a bit more performance. The only place you'll see a 3.2 or 3.5 wheel is for weld notching or gouging. Quite a good product. I like it because it's reasonably indestructible. At 2.5 mil thick, it's double reinforced in the cut-off wheel, and you're not likely to get hurt unless you try and put it through your ear. But I have seen some bad injuries with cut-off wheels on people's faces, etc. But usually there's a loony on the end of the grinder or somebody that's just not taking care. But that's been around for a long time. Suitable for most steels, a little bit of cast iron. Also comes out in the Type 27 wheel, which is recessed or raised hub. 6mm to 7mm is your standard grinding wheel. There are a few other forms, but those two wheels form the basics of what you can get for many, many years. And they were sold into industry by the thousands, and then along came European excellence, and they decided to spoil it for everybody and introduce a new product. Thank God they did. Some of the things they brought to us are just over the moon with performance, but I'll just go through what I have been selling. Obviously that's why I've got these samples. So these aren't superseded, things have just changed a little bit. One that I don't have a sample of here is an aluminium oxide wheel plus lanolin for aluminium. Now, it's a bit of an unusual product. I first saw these brought out by Ferd, the German company, years ago. And you look at that series of some of the other wheels, you could see through them. And I said to the rep, this is bloody dangerous. And he said, no, it's specifically designed. They buy a very high quality resin, use a very little bit of it, and that gives them a big pore space in the wheel. Now, to impregnate the wheel with lanolin for aluminium, they throw a large quantity of finished aluminium oxide Type 27 wheels into a big barrel, put a sucker on the end, evacuate the barrel, and then they add lanolin. Now, evacuating the barrel pulls all the air out of the pore spaces in the wheel. It allows the lanolin to penetrate into the wheel, which is a pretty good idea. You start using them in aluminium, they don't clog up as bad, and they clean up reasonably well if they do. but they do leave a residue on the aluminium that you have to clean off with, trying to think now, Prepsol or wax and silicon remover before you weld. So that was one of the big steps forward. Another thing that's been around for a hell of a long time, gets abused. I've seen them use as cut-off wheels, which is bloody dangerous. I was involved in a big bloody factory incident there with one of the wheels I sold. But go back to the 80s, and it was the AC36 flexible disc, available in 4, 5 and 7 inch. And it could be 36, 46 or 60, but 36 was the common wheel. And that was a mixture of alox and silicon carbide grain. We'll talk more about Silcarb soon. And that gave you the ability to finish both steel products and aluminium because it had the Silcarb grain in it. But they used a very high quality aluminium oxide, very similar to a white 38A tool room alox, and that gave it reasonable aggression. It would grind stainless steel reasonably well, and it was also very soft, so it broke down. So that gave you fresh grain all the time and also prevented good old ALU from blocking it up. A bit like it does cost the patient sometimes, the ALU. And that was the industry standard for quite a number of years. And we sold, once again, large quantities into bus building and boat builders, etc. Now, there's always been in the background silicon carbide, a little bit of an orphan. I only ever saw it initially in sanding discs for work on terrazzo, and it come to shine for flexible discs, and Silcarb was also used in some tool room applications. That's your green wheels for tungsten carbide. Quite a good product, and the big difference in them is that silicon carbide is a little bit harder than alox, and it's also a peaked or very pointy grain. So it's hard, it presents sharp, but it's pretty fragile. And I'll talk about a usage for it shortly. If you try and grind very, very hard with a Silcarb disc or a Silcarb wheel, it'll dissipate very, very quickly. Having said that, they're very, very good for most non-ferrous materials, brass, bronze, aluminium, bronze. They do a fairly good job there. And along comes the masonry industry, terrazzo, etc. And one thing I don't have a sample of here is the Z disc, ZEC. Brought into this country by a few manufacturers. It's a fibre backing, very similar to a resin fibre disc, but on the front it has swirls of grain, and they're 3 or 4 mil thick, a bit like a motorbike clutch. Now, as I said, I brought in originally for terrazzo or ceramic work, but man, do they give mill scale a lift, and that's the hint I was talking about before. And I taught my customers to have 2 grinders, one with a Z disc to get rid of the mill scale, and then either a Cubitron sanding disc or a Cubitron grinding wheel if you want to get rid of a hell of a lot of material. Just go back to the old alox if you want to go steady eddy and not wear the workers out. Now, if you try and use the Silcarb to grind the steel, it just dissipates. So you have to use 2 tools, there's no choice there. In the meantime, there's been a development, probably mid-80s to early 90s, cubic zirconia. And as the name suggests, it's a cubic grain. You get a little bit of a hint in the names of what it is. It's an artificially produced grain, and it's a good old blockhead shape. It's tough. You can use your sanding discs and grinding wheels in foundries. You can belt the living hell out of it. Being cubic, you can actually, when the wheel glazes over, put an old file up in a vise and grind that, and you can freshen the grain up. It can crack 4 to 7 times, and that was one of the original benefits for it. And if it's in a grinding wheel, either straight to zirconia, but usually they mix it with a bit of alox, and the grinding wheel glazes up, just belt the hell out of it, and you've got a chance of it coming good. It's also got one big advantage. Because it's tough, you don't need to put as much abrasive grain on the sanding disc or the coated disc. That allows you to run an open coat disc. Closed coat is where all the grains are packed on. Open coat, you've got a bit of space in between them. And that open coat gives you a couple of advantages. Main one is allowing somewhere for the swarf to go. so you don't have the swarf rubbing as much across the job, but it also lets a little bit of air through and it can cool the workpiece. And a good example, or two good examples, we'll talk a bit later. Flat discs, you can get them in brown Alox or now in ceramic, but brown Alox, blue Zirc, and fibre discs either with a hole in them or Velcro back in Zirc. Very good for aluminium and a lot of other uses, of course. But that was a progression through the industry. It became very, very popular late 90s, early this century, and a lot of hard work was done with it. The product actually came forward, advanced one hell of a lot. Oh, I better step back and finish off some of the earlier items. A few advances that came along. One that was around for some time but we adapted is the silicon carbide grinding wheel, meant originally for masonry. It did a fair job at that. You couldn't really slip into it. On man-made product like terrazzo, yes, it did a fairly good job there. But also on aluminium, if you grease it up, that would slip the aluminium out. It would take off the mill scale on a lot of the steel, and it was a versatile product, but we only sold very, very few of them. Then we had some advances come along in cut-off wheels, and one of the first was the 1mm cut-off wheel introduced by Ferd. All the other manufacturers jumped on board. There were some that I think are outstanding. Tools like this, 1.9mm thick raised hub, dual purpose wheel. You can grind with it, you can sand with it. A lot of people didn't like it because they were trying to do things with it. It was never designed for. Popular in Europe. Here's one by a company I sold a lot of, Blue Shark. They call it a combined wheel, and I sold it specifically for a couple of cases. If you're making road going tankers under the main road specification, all the dogs weren't allowed to be belted off the sheet. You had to cut and grind them. Well, this allowed you to cut with the wheel, grind it about 30 degrees with the wheel, and lay it down and sand with it and get your finish. Now that saved 2 wheel changes for each little cleat you're knocking off. So to me, it's quite a good advantage. Only a very few of my customers took it up, and that's a real shame, but yeah, quite a good product. Another item that came into the industry that I don't think is pushed hard enough, 1mm cut-off wheels just ain't made for fabricators. They're meant for sheet metal workers with a gentle touch who are trying to coerce a bit of accuracy out of the job. They're not meant for a great big gorilla boiler maker who wants to hit something with a hammer and get it done with a bit of grinding. And I think they've been over promoted and abused. We had several cases of wheels year after year. Nothing wrong with the product. They're designed to cut up to about 1.6 material, and guys are cutting 6mm and 10mm plate and bitching that the wheels break. So if you've got a little bit of nous, that is one outstanding product, a Blue Shark. They call it a 1mm wheel, but if you measure it, it's 1.27, so they cheat a little bit. Everybody does. Double reinforced, in my opinion, and externally reinforced. That gives it a lot of rigidity, and it's one of my favourites. I've used it on 6-inch and 8-inch and 12-inch boiler pipe with 1/4 inch or 6.35 wall thickness, and in the 200mm wheel, if you're gentle with the wheel, you'll get 2 cuts out of pipe. If you push it to destruction like I have to because I can't crouch for too long, you'll get 1.5 out of it. And with this product you can actually feel it start to glaze up a little bit, and then it'll break down and cut another couple of inches of pipe. So it gives you a really good demonstration of an abrasive product shedding grain when it starts to get too hot. But yeah, I think that's an outstanding wheel. If you're bent on using European made product, go for the 1.6mm wheel. You get about 80 to 85% of the cutting performance of the 1.6 wheel. In fabrication work you get 3 to 4 times the life. You get the added benefit of not losing any body parts, which I think is a real bloody plus, and they're usually a little bit cheaper. So I've used these myself in cutting that boiler pipe as well as the Blue Shark wheel, much tougher product, and I like that. So I think if I'd like to suggest something to you, use these for fabrication. They're usually A46, which means a coarser grain, and they're a lot more rigid. I've actually heard of a case of one of my customers using 1mm cut-off wheels to shape bird mouth joints in tube. Like, oh God, so bloody dangerous. Special purpose products. Coming back to aluminium oxide, there are a few around in the industry. One standout product is the Rex Cut grinding and blending wheel. Out of the USA, it's been around for 25 or 30 years. Very, very popular over there. Bloody expensive. That's probably $17 or $18 worth of wheel. A little bit of science in it, and sometimes manufacturers get a head start on other people. I've been told by the representative in Australia that it's a urethane bond with cotton reinforcing. Now, who would think of using cotton in a bloody grinding wheel? Somebody's got some brains, and they use a very, very high quality aluminium oxide grain in there. Now, this is a case of making something that performs well with extra dollars. You can always do it if people are prepared to pay. And I've sold those into the stainless steel fabrication industry for probably 30 years. They perform very well, even though it's 36 grit. The urethane bond prevents the grain impinging on the job too much, so you get a reasonably good finish. Good for well dressing. The edge of the wheel is good for doing splashbacks or inside corners. A couple of unusual uses for it. I can't explain why, but it's good for our mate ALU. Cuts reasonably fast, not as fast as the sanding disc, but leaves you a fairly good finish. Now, they're available in most descriptions in A36, A50 and A80, and if you're prepared to spend a bit of dollars to get some performance, I can recommend that. They did have a cut and finish wheel. This was designed, and it says 80T on there. I think it's a 40, 60, 80 grit blend, or at least a 54-80 blend. It is fantastic. It cuts and it finishes. They were fairly dear. I got about a dozen of them in, and I think I had to sell them for about $13 or $14 for a 4.5 inch wheel. They always demonstrated really well, but customers just would not put their hand in their pocket to take it up. Bit of a shame, but that's another case if they lose out, and so do I don't get the sales. Okay, moving along. We had a couple of forays into the industry a few years ago with ceramic grinding wheels. Blue Shark had a play with them probably more recently. The most successful of this type of wheel was a 3M Green Corpse. It's a ceramic grain, but it's not as well engineered as a Cubitron. So you got twice the performance, you pay twice the price. All you saved was the downtime of changing the wheels, but it was a step into using better product. And I would like to see a lot of people experimenting with that. Ceramics, we progressed from there, but we'll show you a few other products to come in with this cubic zirconia. Once again, sanding discs both with the resin fibre backing and the Velcro backing. I love these Velcro discs for sheet metal work, doing outside corner welds. You can shape them, just rip the disc off, put a Scotch-Brite disc on, go back, finish your grind, and then line it up with a black hand pad for number 4 finish and outside corner weld done. Another good concept that wasn't all that popular. Boy, they're hard to take it up, but yeah. Good zirconia sanding discs give you value for money. And of course, we've all been using these for years. They vary a lot in price, they vary a lot in quality. Once again, it's a case of you get what you pay for. Some of the newer ceramic flat discs are absolutely ferocious in removing material, and the Europeans are wondering what the hell we're still using grinding wheels for here in Australia. I will say that they give a much softer feel, and sometimes you can't get as straight a finish. One problem I have with these and with a lot of grinding wheels, I've got customers that go along a weld seam, fore and aft like that, and then complain because the weld seam is dished. If you can only get them to turn the grinder 90 degrees and use the angled face of the flat disc that presents as a flat surface and go that way with the wheel, you don't get any dishing, and when the weld bead is down to the parent material, immediately you're presented with 3 or 4 times the width against the cutting face of the wheel, and you can see it and feel it, and you finish up with a flat weld. So there's another hint for you. Try and get people, fabricators, to turn their grinders by 90 degrees. They scratch their head, they can't see how it works, but take it from me, they do. They really work well. Okay, other products that have come onto the market recently. One product that I find a little bit unusual, Lennox and a few other people have brought out, they call them diamond coated wheels. I don't know if they are true diamond. If you cut metal with a diamond, normally the diamond loads up, but this is 125 by 3mm. It's steel, alright, sticks to my magnet. It's electroplated around the periphery, only about 2.5mm deep, probably 1 layer thick, and they advertise it as 1,000 cuts plus 30 times longer in wheel life. I've only had a little bit of a go with these. They're bloody ferocious. They cut anything. Wood, copper, aluminium, just bloody amazing. The noise they generate, bloody hell. It's a real racket. But if you're going to take one wheel on site and you don't want the inspector to kick you off and you want to be able to cut all materials, yes, what you see advertised on TV does work. But you pay for it, you get 1,000 cuts, probably cost you $18. Cost effective, wear you must, for God's sake. Now, back to general purpose cleaning, and also another item for mill scale, and you've got to be very careful with this. 3M were the big exponent of their clean and strip wheels. It was a very, very coarse nylon matrix, and they really won the game. They had 80 grit silk carb molded into a non-woven nylon. The nylon is just squirted in with a nozzle, and it gives it a very, very open feed. Be careful with all of these open nylon products. They'll take your flash off faster than the saw blade. They'll give you a real hurry up. But no, very, very good product. If you're grinding on an edge or near an edge, always grind off the edge, not onto it, or you'll strip these. But these are very, very good for taking off our made mill scale, old paint, rust, very expensive, about $14 a wheel. Man hour wise, they do a fantastic job. I hope that they take off here in Australia and we get the same benefit that all the big European users have. But yeah, and once again, that's why I made Blue Shark. I'll give them a plug because they're a bloody good product. Getting into what the industry is going to move to, and in a couple of ways you've got to be careful. If you introduce really, really big products, most of the smaller manufacturers drop off. You have 1 or 2 people making really good money. The end users aren't getting a real bargain, and there's no competition in the industry until the other manufacturers catch up. So the end users are getting some really good leaps and bounds, but how the industry will settle in over the next 10 years, I don't know. I will say this, that all of these super abrasives like these and the ceramics, the Cubitron sanding discs, are good at bloody burning out angle grinders. That's one thing they do in a professional way. So just be gentle on your tools. Like 2.5 times the metal removal mate should be enough, don't go for 3. A couple of people moved into the ceramic wheels. That's the Klingspor Act disc. Very, very good. Not quite as good as Cubitron. Priced very well. It's cost effective. Everybody seems to go for the Cubitron for its life, and it's the first time I've seen a resin fibre disc last for a working shift, like an 8-hour shift. But I start to wonder what happens when the backing starts to fail. I've had a few fail on me, and it can lead to a bloody nasty incident. So you've got to watch that, weigh it up one against the other. The manufacturers aren't silly, but let's see how well they go. This is another ceramic product brought out by Norton. They call it the Blaze product. It's got a ceramic grain on it. It has a very, very good backing. It's also available in linear belts, and man, is it good. It's priced at a very good entry point for ceramics, and I don't know how that doesn't command a huge part of the market. That is a very, very good product. And that's another one. I sold a little bit of Move Industries gear. Not too bad. I think you get good value for money. We'll see how the ceramics go. There's now Cubitron 3, which was available just before I stepped out of the industry, and it performs really well, but once again it's killing grinders. Okay, I'll put you back out away from the Zoom, give you a bit of a good night, bye note, but by all means hit me up with questions about what can you use to get a better finish, a faster cut if it is available, or a bit of safety, and safety is something you really have to look at. I'll zoom you out again. Well guys, I'm back with a bit of a goodbye. That was a short session on some basic abrasives knowledge. I hope that gave you a few insights in what you're doing and how it should work. As I said, if you've got any queries, hit me up. If you want me to expand this series on abrasives, especially into the coated field, I can do that. I will be running a training course on all of the bonded type tool room wheels. It's called abrasive machining and tool room grinding. I'm getting my material together for that, and I'm trying to find a format where I can present it as a course for a very, very low price, and I think you'll be happy with the information that you get out of it. So from an old fart giving you some lessons, goodbye for now. Please like and subscribe, give me a few watch hours. Bye guys.